Hey math fans, we're on section 2.4.2. Let's get started. In this section, we're going to learn about rate of change. And the rate of change, or abbreviated ROC, is just going to be the change in y over the change in x. You've probably seen this formula before. It's the same formula as the slope formula. Rate of change problems are easy for linear equations because it's always going to have the same rate of change. It's going to always be rising the same amount as it is running the entire way. So it doesn't matter what the 2 points are, it will always have the same rate of change throughout the entire function. It's a different story when you're trying to find average rate of change for an exponential function. This is going to be the difficult part. It's going to depend on which 2 points you choose. As you can see, there are 2 points on this graph that give a rate of change of 0.44. However, when I change the 2 points, the rate of change changes. As you can see, on an exponential graph, as the points change, the rate of change will be changing. So the rate of change is going to be very dependent on what the domain of the function is. And as you can see, an exponential graph gets even steeper as the points change in this particular function. Janie invests $1,300 at a rate of 2.6% compounded monthly. The function models this situation as f of x equals 1,300 times the quantity of 1 plus 0.026 over 12, the quantity of which is raised to the 12x power. And it says, find the rate of change for the interval, and this is the most important part right here. What will the rate of change be in the domain 1 to 4? Very first step, simplify, make a table. So I've simplified it to f of x is equal to 1,300 times 1.002167. You can round however you would like. I would say at least take it to 3 or 4 decimals, raise that to the 12x power. Why am I choosing these two numbers? Well, I need the interval from 1 to 4, and there it is. If I'm going to be choosing, this will be my x1, this will be my x2, this will be my y1 and my y2. And all I did was substitute 1 in here and 4 in there because that was my interval. Using Desmos, I've graphed the function, and as you can see, it's definitely exponential, but when you zoom in on just the domain interval of x values between 1 and 4, it almost looks like it's a linear equation, but it's not. We will be using that rate of change formula to get our rate of change here. Now, it doesn't matter which one you choose to be x1 and y1. I have chosen in this particular problem for this to be x1 and this to be x2 and this to be y1 and this to be y2. I've plugged them in accordingly. You will get exactly the same answer if you switch them, but you will get a wrong answer if you don't keep these numbers together. So you will get exactly the same answer if I did 1 minus 4 in the denominator and 1,334 minus the 1,442. You will get exactly the same answer of 36.04. So the average rate of change for this interval between 1 and 4 is $36.04 per year. And that's going to do it for this section. We'll see you in class.